Good evening, everybody. I'm Bert Dicht. I'm Vice President of Membership for the National Space Society. And on behalf of my colleague, Larry Ahern, Vice President of Chapters, I would like to welcome you to our NSS Space Forum, NASA's Space Launch System, Countdown to Launch. So again, this is one of our series of our NSS virtual space forums, including our town halls. But tonight, we also like to welcome the Huntsville, Alabama L5 Society, who's also jointly sponsoring this space forum. And thanks to Robin Scott, who's also on our panel this evening, for helping get this organized. As always, I'd like to go through a little bit about some virtual etiquette, a little bit about what's coming up with NSS, also our space forums and town hall schedule. Then we'll get right into our program and we'll close out the evening. As always with our virtual etiquette, ask you to submit a question using the Q&A function. It's best because this is seen directly by the panel, goes right to them, and it's easy to pick out the questions to be asked. You can use the chat function to put a question in, but we'll have to find that. And of course, all the other chat gets mixed in with that. So sometimes it might be easy to miss a question. So if you can, use the Q&A. If you are using the chat, I ask you all to be respectful and of the panelists and the audience. And it is best to view the session in speaker mode if you're using the your own Zoom tool, but I will have it in speaker mode from our presentation standpoint as well. I always like to remind people, if you are enjoying the programs like these space forums and town halls, please feel free to make a donation to support the National Space Society. Again, everything we do is done by volunteers, and all of the support, all of their donor funds go directly to our programming. So please give to our cause, and we'll be sure to put this into the chat. Finally, in terms of just our housekeeping, if you can, at the end of the session, take a few minutes to complete the post-space forum survey once you exit the session. It's very fast, just a few questions. It is completely anonymous. And I can tell you already, it's helped us quite a bit in planning future events and showing what you are interested in and what types of things you're looking for. In terms of what's coming up, I'll be honest, we're still working on our fall agenda, but what's coming up in 2 weeks from tonight, David Chudwin, a longtime NSS member, he was a 19-year-old college newspaper reporter who covered the Apollo 11 launch. And he wrote a book, I Was a Teenage Space Reporter. It's a fascinating story. And I encourage you to join us in 2 weeks to hear about that. We're working on one for the 9th of September. We are going to take about a three-week break between the 19th and September 9th. So just remind you about that, look for that. And then we've lined up already someone for the 23rd, Marianne Dyson, who is actually, again, a longtime NSS member and a former shuttle mission controller. She's written a book about her own experiences, but her newest book is called Shuttle Mission Control, and she highlights and profiles about 20 different shuttle controllers. So it should be a fun, interesting discussion. And you can always access our recordings on space.nss.org. On the Space Forum site, we'll take you right to all of our recordings on our our YouTube channel. So now I'd like to start and introduce our guest speaker for this evening. Again, our topic is the NASA Space Launch System, Countdown to Launch. And we've got Brian Matisak, who is the Deputy Manager for Systems Engineering and Integration Office on NASA's Space Launch System Program at the Marshall Space Flight Center. And Brian got his aerospace engineering degree from Auburn University in 1989, and he earned a master's degree in industrial and systems engineering from the University of Alabama, Huntsville in 1998. Before his current position at NASA, he worked on what is called the Integration Analysis and Test. He was the Integration and Analysis Test Manager in the Reusable Solid Rocket Booster Project Office during the Space Shuttle program. As I said, Brian is currently the Deputy Manager of Systems Engineering and Integration Office for the Space Launch System. In this capacity, he provides expert technical and programmatic leadership for the systems engineering and integration functions of the vehicle for the SLS program. So I know you're in for a very interesting presentation. I would like to just preface this by saying tonight's presentation is about the technical. We know there are a lot of things, a lot of interesting aspects to the SLS program, but Brian is going to be talking about the technical and getting ready for that first launch. So if you can actually keep your questions to that topic, that would be great. So what I want to do now is introduce Brian, and then I will start sharing the presentation for him. And Brian, it is all yours now, and I'll bring up your presentation.
Awesome. Thank you, Bert. Hey, and I want to thank all of you for joining this call tonight. I know that you're all space advocates, as I am. I do want to share with you all tonight our progress, as Bert said, in getting Artemis I to the pad. I'll tell you, I was down there 2 weeks ago. I was in High Bay 3 going up and down the platforms, and this feels a whole lot to me like STS in terms of preparations. I'm very fired up. I'm inspired. After working all these years on this program, we are finally here, and I want to hopefully you will see in the presentation and how I present the content that the folks on this program that are working to get this rocket to the pad, we are all inspired as well. We all have a motivation for getting back to the moon in 24. That's our goal. That's our current plan. And I just, again, I want to show you guys tonight progress, not only on what we're doing for Artemis I, but the progress we're making on Artemis II, 3, 4. And I'm going to touch a little bit on block 2 in the presentation. So we're looking out 9 flights already, but obviously the focus is getting the rocket to the pad. Let's get through our integrated test and checkout aspect that includes wet dress rehearsal that shows that the vehicle is ready to go fly. And then again, if all goes well, we'll be ready to fly Artemis I before the end of the year. So again, hopefully my message to you tonight is one of inspiration. I'm going to assume that this group knows a little bit about what our capability in SLS, so I'm not going to go through a lot of stats. I will do a rack and stack of what the vehicle design looks like, but again, I don't plan on going through all the details. However, I will answer any question you guys have to my capability with this rocket. Again, my background is boosters from the shuttle project office. But I obviously, from an integration standpoint, I've got experience in all the elements. So, so I think with that, and I did want to just add to what Bert said earlier. You know, tonight's about showing you the progress of this vehicle. I really don't want to get into budgets tonight. You guys know a couple months ago, this president did submit a budget request that is 6% above what we had last year. So in terms of advocacy of this, not only of this administration, but of the bipartisan support of Congress, we do have that backing. And so now, to me, it's about executing on our commitments. So and that's really all I want to say on that. So okay, so you jump to the first slide. So again, I'm assuming that most of you know what this rocket looks like and how it's put together. This is an artist rendition that I will tell you in the next month or so, it's going to look, the real thing is going to look a whole lot like this artist rendition. I think most of you know it's 322 feet tall. It weighs almost 6 million pounds. The Block 1 vehicle design will provide 8.8 million pounds of thrust. It will get 27 tons to TLI. And of course, you know, these first handful of missions are for Orion, with the goal again of getting Orion to the moon and part of the Gateway program as well. So, you know, my takeaway message to you all is this rocket is really the foundational asset for the program. So, so we need this. We understand the importance, big picture, of why we're building this in the big scheme. And so I can tell you the folks at Marshall, the folks on this team are inspired every day to come into work because we understand what we're doing, how this rocket is helping to benefit this nation in terms of space exploration. So let's go to the next slide. So a little bit of background again, more stats. I don't want to go into the details because I'm assuming that this group is educated on our vehicle's capability. But you can see first 3 flights are going to be the column on the left-hand side. Artemis I, II, and III, 8.8 million pounds of thrust. Again, the objective there is getting the Orion vehicle to the moon. So let me say a couple things though then about the design. It's 2 5-segment boosters. They're heritage shuttle. We've got 16 RS-25s, aka SSMEs, asset holdovers from shuttle. They're all ready to go. There is an effort underway. We call it the restart activities. That we've got Rocketdyne building the 17th and subsequent RS-25 for flight assets. Artemis V flight assets and subsequent. Let's see, the upper stage is interim cryo propulsion system, aka the old DCSS. Teledyne Brown is building the LVSA, the Launch Vehicle Spacecraft Adapter. We've got a local in-house Marshall capability for building the Orion Spacecraft Adapter, basically the attach point between us and Orion. So that kind of in a nutshell is what our Block 1 design looks like. If you go to the middle of the page, the Block 1B design is a EUS and exploration upper stage. It's the next generation upper stage. It's going to have 4 RL-10s at the bottom of the upper stage. That provides a whole lot more capability than what we're currently able to provide for the first 3 flights. The universal stage adapter as a Dianetics design. They've subbed that with RUAG. That is going to be again the adapter used to enclose the EUS. And again, you can see it does have a capability of getting up mass to the tune of about 36 to 38 tons to TLI. So you can see a pretty significant increase. And then ultimately, and again, so we've got eight flight sets of solid rocket booster cases. And so first 8 flights are gonna use those steel cases. The booster office is currently in a design mode for the Block 2 upgrade booster. They've been working that with Northrop Grumman. Again, that's for Artemis 9 and subs, and you can see the capability, up mass capability for that rocket. But again, that's the 9th flight. We do have a team that's looking out that far, but obviously our focus is today is on that rocket to the left. So let's see, that's all I think I wanted to say about that slide. Let's go to the next slide if we can, Bert. And so more stats about what this rocket can do. Again, you know, double the volume of any currently heavy lift vehicle. You can see the stats here. We can get more up mass to the moon in fewer flights than any other rocket that's currently on the market. Again, our focus, the team's focus, is to get Artemis I off the pad and continue our success beyond Artemis I. That gets the crew back to the moon by 2024. So again, the stats speak for themselves here. It is a game-changing rocket for the future. Next slide. So I just went over the elements of this rocket, and again, you can see, and we'll see in future slides just kind of where we are. Again, I was down there last week. It is a behemoth of a rocket. See the boosters, the engine core stage, and then the ICPS. Let's see. I think that was it for this slide. Let's go to the next slide, if you can, Bert. So a lot of testing to get to this point. What you don't see in here is is some of you with the shuttle heritage know that we always tested our SRBs before we flew them. Not the actual ones that fly, but obviously the test ones to make sure that our design gave us confidence that we were ready to launch the bird. So that's not included in this testing page, but you can see again on the left-hand side the hydrogen tank. So let me step back a little bit. The upper left-hand figure, lower left-hand figure, and then the figure on the bottom left, those are all structural test article tests that were conducted at Marshall with the core stage structural test articles. And those tests, as many of you know, with shuttle heritage, give us confidence that the design is a good one, and it is safe to fly with incredibly high margins, or I don't want to say incredibly high, adequate margins to what we were used to certifying to from our heritage, from Apollo, from shuttle, and now for this vehicle. That figure, the figure in the top middle, is also setting up the test configuration for these STAs. The figure on the right are again, that looks like that was our green run tests down at Stennis. And then again, I take it back, looking at the bottom right, that was our last solid rocket booster test out in Utah. That gave us confidence that this booster was ready to fly. So a lot of tests, a lot of good data from our tests that are giving us confidence that the design is good to fly. So, Bert, I think that's all I wanted to say about that. Let's go to the next slide. We're going to kind of talk a little bit about green run testing. So this was the testing on core stage 1 that we conducted, a series of 8 tests that gave us confidence that this that CS1 was ready to ship to Kennedy and to stack with the boosters, and gave us confidence that it is ready to perform on launch day. Really think that's all I wanted to say about that. Again, you know, test like you fly sort of mindset to the extent that we can, and I think we showed that with the green run test. So it was an impressive test. I sat in on it from the HOSC and was monitoring the data, and the Boeing NASA team did a great job, and as well as aerospace AR. to get ready for shipping CS1 to Kennedy Space Center. So I think that was it on this slide. Let's go to the next one.
Go for engine start.
H-buoys are on and engine starts has been okay.
This is a 35-second clip of the second green light.
Personnel, please
Very
proceed to
impressive.
monitor your systems and grass is in control.
Aerojet Rocketdyne engines perform as designed, as you would expect. Again, these are very big shuttle engines. Flying them in this 4 engine cluster obviously is new to us, so that's why we had to go do this. Okay, so and again, I talked earlier about the progress of where all the hardware is down in High Bay 3. When I was down there last week, we had just stacked the ICPS, and we were waiting on the Orion spacecraft adapter structural test article. I'll give a little bit of background on that. The Orion right now is over at the what we call the Launch Abort System Facility, LASF, in down at KSC, integrating the LAS with the Orion. And so, in an effort to kind of be smart with our scheduling, we had the opportunity. Let me step back. At the same time, we are also awaiting some secondary payloads to be integrated into the OSA. You can see on the bottom left-hand side, the CubeSat installation ongoing. That work was done in the Space Station Processing Facility. There are a couple more secondaries that we've got to load over at the Multipurpose Processing Facility, the MPPF at Kennedy Space Center. And so while that work is still going, we are going to continue on with what we call our ITCO tests, integrated test and checkout tests. It's a series of 13 or so tests that we do prior to T0. So what we're going to do is we're going to bring the spacecraft adapter in. It's actually ready to go as soon as we get done with some core stage power up activity later on this week. Going into next week, our plan is to bring the structural test article from the Orion spacecraft adapter over, mate that, and then bring over, and you'll see it in just a minute, what this Orion, we call it Orion simulated article. You'll see that here in just a minute. We're going to stack that. We're going to go through a series of tests. We'll take it out to the pad, then we'll bring it back. Then we're going to go ahead and mate the real thing with the OSA and then the Orion, and then we'll bring it back out for WDR before we're ready to go fly. So we've employed some pretty unique strategies to try to do all we can at becoming as efficient as we can with the schedule down at Kennedy. So again, a lot of good work from the KSC team, the TOSC, KSC's contractor, EGS's contractor on stacking this rocket. You know, the thing that I've got to keep reminding our guys is, or our folks is, you know, this is not STS-136. This is really STS-1. Yes, we still have some folks down at Kennedy who have experience in stacking, but it's been 10 years since we've stacked a space shuttle. So we've learned, I will just tell you, as you would expect with any first flight vehicle, we're kind of learning a lot of these things as we go. You know, we put the plans in place, the work plans are in place, the O&M requirements are in place, but until you actually put it all together and then try to test it out, you know, that's something, you know, it's unique, and everybody knows that. And I think the management team at Marshall, a lot of us, many of us, most of us who worked shuttle we remember some of the scars. We remember some of the lessons learned that we have to keep reminding our guys, and gals, our younger crowd that has come on board. That's the next generation of leaders at the center. That, look, this is first flight, so we gotta learn. We gotta work together as a team. We've got to communicate when issues do come up. We work those together with the Kennedy team, because again, we gotta get across the finish line together. So and that's the philosophy that this leadership team is trying to instill in our workforce at Marshall. So I think I've said enough about where we are with Artemis I. It is just really exciting. I'll tell you all, it is really exciting to be down in High Bay 3. And of course, the platform configuration is different. The EGS guys at Kennedy, they did a great job at redesigning High Bay 3. Kudos to them in testing and getting it all together. And because so far it's all working, it's working like a charm. So that's really all I wanted to say about Artemis I. Let's go to the next slide. There was a lot of work going into this short little clip, as you can imagine. This was many months in the planning. This 35-second clip just doesn't do justice to all the work, all the planning, the ability to work together as an integrated team between the Marshall folks and the Kennedy folks on pulling that off. We knew we had challenges, impinging challenges, with CS1 coming down and being mated to the boosters. You can't really tell it. You can't tell from this video here, but those boosters were pulled back, much like the way we did it on shuttle when the ET came in. Just an amazing accomplishment by the team. And again, remember, this was the CS1, just a couple months before this video was in the B2 stand at Stennis, just having completed the second green run test. So you can see that little shift there, that little move that they had to make sure that they could get it down in between the two boosters. And Bert, I don't know that. Yeah, okay, so it stops there. So again, let me just say, that was a short clip, but a lot of work in the making, and everybody realize that, this is first time. This is STS1 all over again. So just our hats off to the team for pulling that off. I talked to you about the Orion mass simulator. So that's what it looks like now. It's sitting down at Kennedy. It is ready to be stacked. And that's an artist rendition in the middle of what it's going to look like. And we need to obviously get that stacked prior to going into a series of modal tests that our design team needs to have conducted to verify that what we've modeled this vehicle resonating at is in fact going to align with the testing. So that IMT, we call it an IMT, integrated modal test, that's coming up here in the next couple of weeks. We've got a group of folks out of the test area that are on point for getting that done, getting the data, bringing it back to our design engineers to make sure that basically a validation of what our models are telling us that the modes are on this vehicle. So, and I'm having a hard time. I guess I need to look at my charts here. I can't really see what's on the right-hand side. So on the right-hand side of this chart are these secondary payloads that I think at this point these two have been integrated into the OSA And again, as I mentioned earlier, the Orion spacecraft adapter, that interface between our rocket and the Orion, that is currently over at the MPPF, and we're waiting on a couple more secondaries to come in and get them loaded in the canisters before we bring that over to the VAB to stack with the rest of the rocket later on in the flow later this year. So again, I just you look at this and it just amazes me that here we are after all these years. It's all finally coming together. It is very inspiring. I think it's very inspiring for this nation to see this progress. Okay, hey, let's go to the next slide if you can, Bert. So in the meantime, as we're stacking the rocket, Charlie's team, Charlie Blackwell Thompson, she's our launch director for Artemis I down at Kennedy. She's getting her team ready. They've been going through a series of sims, simulation missions. Our team within SLS, we've been conducting a series of internal sims, and we have just now started up our joint integration sim activities with not only the folks at Kennedy, not only Charlie's team, but the folks down in Houston, the FOD folks that are exercising the day of launch iLoad update process. That as many of you that work shuttle is a critical component for ensuring that we're ready to fly. So testing is underway. It is going to pick up big time. The end of this month is going to be packed with sims. We're also going to have, in addition to, let me step back a little bit. So some of these sims that Charlie's team are conducting, some of you remember from shuttle, are comprised of the terminal count sims, where the team gets exercised. The joint launch control team and the support launch team go through a series of simulation conditions where during the count we get thrown issues to go work to make sure that the communication process for how we address the issues and how we rectify them and communicate them back up to Charlie that we're ready to go is done in a most efficient manner. And I'll just tell you that we've had some sims already work to where we've had to just tell Charlie, can't do it for today. It's not going to go. We're going to have to reset. I will tell you that it's going to start getting more interesting in this sim environment when we then bring in the mission management team in terms of decision making. So that's going to add a level of complexity and a level of communication that, again, we're going to need for day of launch. As many of you know, Mike Serafin is our mission manager for the first flight. And later on this month, we're going to start introducing the MMT into these sims. So that view on the right, I can't tell if, I'm sorry, that's the HOSC. So those of you that work shuttle and worked in the SESC, you will notice that configuration looks a little bit different from shuttle, but it's been reconfigured to support this SLS design center team in assessing the health and readiness of the rocket to go launch. And again, we're gonna, much like how we did on shuttle, we're gonna use this team to inform Mr. Honeycutt, our program manager, and Dr. Blevins, our chief engineer, our readiness to support launch, Charlie's team, and launching this vehicle. So again, not only are we stacking this rocket, we're prepping the team for day of launch activity. So I hope you all can glean from what I'm sharing with you. It is such an exciting time to be working on this rocket, not only from a Marshall Space Flight Center standpoint, from an enterprise standpoint, from an agency standpoint, from a nation standpoint. Folks at all the centers that are supporting this launch are all gearing up. So again, I've worked 10 years now on this rocket to get to this point, and I'm thrilled. but again, we got to stay focused on the task at hand, at getting the rest of these tests conducted, completing the sims, and going up the chain, letting agency leadership know that we're ready to fly. Okay, Bart, let's go to the next slide. Okay, so not only are we focused on the success of Artemis I, in the meantime, we've got a lot of hardware already built, ready to go for the second flight. You can just see, kind of looking around on this chart, the stage adapter is in work. The booster segments are all completed. They're sitting in the barn at a promontory, just waiting to be shipped down to Kennedy. Down at Michoud, all the major components are for Artemis II, for core stage 2, are ready. We're in the process now of joining all the components. And as I mentioned earlier, we've got 16 RS-25s from shuttle that, of course, four are on Artemis I now, but the rest are in storage, just ready to go down at Stennis. We've completed the Teledyne Brown is completed, welding, all the welding parts to the LVSA. The RL-10 engine it was supposed to ship end of July. I think it may already be down at KSC. I don't remember, but that upper stage is ready to go. And then again, you can see kind of where we are with the rest of the hardware, the core stage 2 hardware down at Michoud. So we're, one of the things that I did want to emphasize from a lessons learned perspective, our efficiencies between putting together core stage 1 and core stage 2 were significant. We have realized about a 50% improvement in schedule between Artemis, the core stage 1 and the core stage 2 hardware. I know that was one of the questions out there of what are some of the lessons learned that we've gleaned so far. And I'll just tell you again, it's first flight hardware, that transition from first flight, learning things kind of the hard way on the first flight, and transitioning those lessons learned to the second flight have been realized. So we're taking advantage of those efficiencies. Let's see, Bart, let's go to the next flight. I mean, next slide. And again, the Artemis III hardware, we've got a lot of it. A lot of it is already is ready. The solid rocket booster segments, 5 of the 10 are complete. The RL-10 engines are complete for ICPS-3, and you can just kind of look around and see the progress that we've made. We are cutting hardware to the other elements. So, third flight's out there a ways, but we're already ready. And remember, Artemis III is still the Block 1 configuration. Artemis IV will be the first flight with the upper stage, the EUS exploration upper stage. Let's see. I think that's all I wanted to talk about here. Bert, if you can go to the next slide. So you can see from what I'm sharing with you all tonight, I mean, the progress, the momentum that we're carrying forward from flight to flight, it's real. The hardware is real. And so now, again, it's just a matter of lessons learned from flight to flight that we're implementing. We've got some just really smart, incredible, innovative teams for all the elements that we're taking advantage of to find efficiencies moving forward. Let's see. So, this is, I think this chart speaks for itself. You can, I think I've alluded to, or I've touched on some of these benefits. There's so much benefit to be gained with this national asset, and it's, it all speaks for itself right here. So, Bart, that's all I wanted to say here. So, I just wanted to close on just letting you all know that this is happening. It is real. I'm fired up. I'm inspired. Our team, the teams at Marshall, the teams at Kennedy, the teams at Johnson, the teams at Glenn, the teams all over NASA are so ready to fly. But I will also tell you too, a lot of our lessons learned is we will launch when we're ready. I know that there's always that, and those of you that work shuttle, you all remember this, this launch fever mindset. I think a lot of us do have it, but again, from a leadership standpoint, we're gonna launch when we think we're ready to fly. So, Bert, that was my story, and I hope it was inspiring to you and to the other folks that are on this call tonight. And I hope you guys can glean that I'm fired up. I can't wait. I plan on being in firing room 4 for day of launch. I can't wait to see this rocket go uphill. So with that, Bert, I'll hand it over to you again, and I'm ready for any Q&A.
Very good. Thanks so much, Brian. It is really exciting to see it all come together, and I know we're all looking forward to that launch date. So let's see if we can take some questions. There's a lot of chat. There are quite a few questions in Q&A, and we had a number that were submitted prior. So let me try to tackle a few that were submitted by those who were registering. What do you think were some of the main technical challenges in developing the SLS?
I will tell you, so boosters are heritage, but having said that, we had to go to a new PLI propellant liner insulation design because of the asbestos that we had in the shuttle insulation that we promised our government that if they would just give us a kitchen pass on letting us use that asbestos for shuttle, that we would come up with a new design for this next rocket. And I will tell you the properties in this insulation, that asbestos rubber insulation that we used on shuttle worked like a champ. We did identify some challenges with that interface. We had to go through a small redesign for this rocket, again, because of the kicking out the asbestos and putting in this new material. So you would think that even for heritage shuttle boosters, that there would be no issues, but we did have challenges that we overcame. I would say that probably our biggest challenges, technical challenges by element, have been the core stage, only because so it's basically, you would think it's an external tank with 4 SSMEs on the bottom of it. Boom, easy. No, not that easy. Not that easy. Welding the locks and welding the LH2 tanks was a challenge. We did have a lot of technical challenges down at MAF while we were putting together this the CS1, but we eventually got there because, again, we've got just a world-class design team. Those are the ones that come off the top of my head. Those were our big challenges.
Great. Were there any issues with storing the RS-25 engines? It's been a long time since they were taking off shuttle, and the ones that were taking off are going to be used on SLS. How do you keep them flight ready?
The folks down at Stennis, the Aerojet Rocketdyne folks, have done a great job of keeping these remaining 12 engines now well preserved ready to go, ready to pull out of their protective covers, if you will. So they're ready to go. I will tell you that that Johnny Heplin's liquid engine office, working with AR, have done a great job of getting these things stored. And when we're ready for the next 4 to get mated to CS2, we'll pull them out, we'll inspect them, and then we'll ship them to MAF. So I'm confident that we're going to have 16 engines ready to fly for the first 4 flights.
Great. One person asked about the processing time, or once the SLS rolls out, Artemis I rolls out to the pad, how long is it anticipated between that point and launch? I know things could obviously change.
The game plan is the game plan early on was 7 days, and then as we got more into the details as to what had to get done, we're now targeting about a 2-week time period from the time we roll out until we launch. But again, this is STS-1, so we all have to remember that we've got a plan, and hopefully we'll be able to execute to 2 weeks. But we're also putting in provisions, working with the range on, can we go a little bit longer than 2 weeks? But right now the plan is roll out and launch within 2 weeks.
Are the solid rocket boosters of SLS going to be reused?
No.
We're
not going to reuse them. What we wanted to do to optimize, to get the most payload up mass that we could with this rocket, we made a decision early on that we weren't going to go retrieve them and bring them back. And as an old booster guy, I can tell you that I worked many retrievals. There was a part of me that had a hard time letting go of that concept, but I understand big picture wise. We've got plans in place for the redesign of those solid rocket boosters with the upgraded booster for the 9th flight. But the thinking, the trades that we did back early on in the program was, it was going to be it's not buying us enough of a cost benefit for the payload up mass that we can get by not putting the chutes on. So we made that decision a long time ago, and that's well behind us now.
Oh, very good. When is the first crewed flight planned for?
Second flight. So the Kennedy guys right now they are already working their mobile launcher designs for the emergency egress system. I don't know where we are on selecting the crew yet for that first flight, but I'm sure we're getting pretty close to making that announcement. So again, this first flight, we're gonna test out the rocket, test out the Orion, take it around the moon, and then bring it on back. So, but again, second flight is our plan.
Very good. When the video was showing about heavy lift day, and you actually touched on it as I was thinking about the question, I remember when shuttle was shut down and all those people at KSC who knew how to stack and launch rockets, unfortunately, were let go. So just wondering about the training involved with getting a whole new group of people to stack and launch rockets, and how difficult has that been?
Well, I would tell you, yeah, it was a challenge, and I don't want to speak on behalf of the Kennedy guys as to how they did it, but I will tell you that there was a contingent, just like at Marshall, there was a contingent of experts, of folks that have been through this before that were carried through to this program. So and a lot of the leadership at the Kennedy Space Center for their contractor, aka the next version of USA, the TOS contractor. We did have a lot of experienced carryovers that were, that are helping to shepherd this new group of techs down at Kennedy. I would say, Bert, a whole lot like I would guess. I didn't work STS-1, but I would guess that there were a handful of folks down at Kennedy that worked Apollo Soyuz that probably that knew stack that were carried on to help us and help that team down there to stack STS-1. So I would kind of liken it in that same sense. Yeah, it's a new group, but we've got a mixture of young folks who haven't done this before with some subject matter experts from Shuttle that I worked with on Shuttle and I work with today. And as a team, to me, here's the key is things aren't going to go right. We're going to inadvertently do things we didn't mean to do, but this team is committed to working. Okay, here's the issue. How do we go to resolve it? And to date, I think that's worked very well, and it's a testament to this team, this NASA team at Kennedy and at Johnson and at Marshall.
Great. Maybe this is a fun question or something to honor the past. Are they planning to invite any retired Saturn V Apollo people to see the launch?
Hey, I tell you what, if you get me a list, we will make that happen.
That sounds great.
I don't want to speak. Twyla's probably telling me, no, don't say that. But look, I mean, we also need to honor our veterans and from former programs. And I'll tell you, if those requests come in, we will look at those and we will make every opportunity that we can because this is our rocket. This is the nation's rocket, and the folks that work Saturn were the foundation that got us through Apollo, that got us through Shuttle, and got us to where we are today. So I tell you what, I'd like to meet a couple of those guys. I really would. I don't know how many of the old Saturn guys are still around, but I certainly would like to get a chance to chat with them.
Yeah, maybe the NSS can do something about that, make some connections. We'll see what we can do. I would love that. Yeah, that's great. So let me go to some questions that were submitted by the audience now, and I'll try to go through some of them pretty quickly. Carl asks, is there any duplication between SLS and any of the commercial space programs?
I will tell you that we are leveraging, for example, on the second flight, we're leveraging some of what the commercial crew program folks have learned. We have what's called an emergency detection system, EDS. It's part of the it's part of the ICPS for the second flight. Because we've got astronauts on the second flight, we were motivated for making sure that that we had a system in place, a smarter system in place that could detect when hazards were about to come up and could help us make better decisions if we had to go into an abort mode. And a lot of that, what the commercial crew program folks are doing in that realm, we're taking advantage of. We are closely partnered with commercial crew. I will tell you that. So things that, and of course we've got folks at Marshall that are working on both programs. So we leverage anytime there's an opportunity to leverage lessons learned on the commercial side. We look for those opportunities.
Very good. I think you answered this question, maybe it was on the first slide as I recall, but someone was Jeffrey was asking how many people are working full time on SLS. I think I remember like 3,600 or something like that. It looked like that. Maybe I'm wrong. I can go back and look at the slide.
I honestly don't remember. Let me see if we have anything. We say anything about that. I honestly don't know how many folks are working the program right now. I will tell you, it's all hands on deck, and it is. If one group is having an issue, we're circling the wagons. And when our organization, the organization that I'm the deputy manager for under David Beeman, Systems Engineering and Integration, we have got a lot of experienced folks from Shuttle who, like me, worked in a project office, an element project office, if you will, who now have the opportunity to come into what we call a level 2 organization and kind of look and see what the other elements for this rocket are doing, how we're integrated, what integration issues we might have between elements. And so again, I'll tell you, we're doing what we can to leverage that experience for this first flight.
Right. I just went back and looked at one of the early slides. I think you had it in there, about 3,800 suppliers and about 60,000 people involved. So a pretty good number.
Yep. Okay. I did. You know what? I glossed right over that. But I'll go back to, at this point, it is getting this team across the finish line. Mr. Honeycutt and Mr. Cianciola, our program manager and deputy program manager, are big advocates on, guys, this is a team. We learned all this from our center director, Jody Singer, who I used to work for. She is all about the team. This is about the team, and it's really about the family. So I think that mindset and that culture has been instilled in those of us that work the other program, that are trying to again continue that culture with SLS.
Very good. Another question from Jeffrey. What materials are the rocket engine bells made of?
Jeffrey, I will tell you, if you Google RS-25 engines and nozzle engines, you will get your answer. Again, I'm a solids guy. I don't have that experience, but I know the guys that know that.
Very good. Phil was asking about what parts are reusable, and I think you touched on that. There really aren't any, right?
Correct. Not for this rocket.
Okay, great.
Well, okay, I take that back. The Orion.
Oh,
We need the Orion back because they have got avionics hardware. They've got components in the Orion that we need for the second flight. So let me restate my answer there.
Okay. Bill was asking for the integrated modal testing. What's the mechanism for inducing the modes?
I can get you that answer. I don't have it. But the Rusty Parks and the folks out of our ET40 organization have all those details. Our chief engineer, John Blevins, came out of that discipline. We've got all that data. I don't have it to memory.
Very good. Yep. Let's see. Question from Tom. With no mobile or rotating service structure built for the SLS, what is the planned time from? Oh, I think you touched on this. The time from rollout to launch, considering Florida weather dynamics. You said about a week, right?
Well, the goal is 7 days, but I think we're all coming to the conclusion that it's going to be more like 2 weeks. So, we can access the hardware from the ML deck. That piece on the mobile launcher that's basically goes up against the booster haunches. But you're right. For this rocket, we don't have access to our forward skirts, the inner tank like we did on shuttle. So, but the concept and the design that we are implementing is almost like a ship and shoot. So get it all ready in High Bay 3, get the FTS hardware connected, do the testing, send it out to the pad, do a little bit more pad testing, and then let's launch.
Another question from Jeffrey, and I guess about the mating. Interesting, and maybe this would be better for one of the people at KSC, but asked, wouldn't it have been simpler to mate the SRBs to the core stage rather than trying to slip the core stage between the two SRBs?
So I will tell you that every opportunity that we had to take advantage of our experience on how we did it on shuttle, we did, and this was no exception. So the team down there, we, for 135 flights, we just we pulled the boosters, we spread them apart, and we brought the tank in. A little bit unique scenario, because core stage 1 is designed a little bit differently than ET was, we knew we had some impingements that we had to figure out how to modify for this stacking operation, such that we wouldn't contact CS1 with the boosters. And you know, you plan your work and you work your plan, and there were no issues. So that, you know, happy to report this was a case where we took advantage of our experience, and it benefited us.
Great. Let's see, a question from Ronnie, just asking about any additional information on the missions for Artemis I, 2, and 3, and the others that you hinted at this point.
I would pass that on to Twyla. We have got within Marshall, we have an SLS homepage that provides all that information. Again, I can't go into a whole lot of detail. In fact, I can't go into any detail on how we're going to get there for boots on the moon by 24. But I can tell you that that we do have that plan ready to go. So it just, again, it's embargoed, I think, at this time, and I want to err on the side of caution here, and I don't want to say too much about that, and just want to avoid getting in any trouble on that. So, but suffice it to say, we have got a plan in place for getting to the moon by 24.
Great. Because of the long lead time to get SLS going, someone was asking about the technology, and you know, where the things need to be updated as you were progressing along in putting the SLS together.
Okay, so you know, we tried to parlay as much of our shuttle experience into the Block 1 design. Early on in the program, our chief engineer, Gary Lyles, he chartered, we call them the RAC teams. I can't remember what RAC stood for, but it was basically 3 or 4 teams that said, okay, go off and you come up with your designs and bring them back to me and our program manager, and we're gonna, based on what you were sharing with us, we're going to decide what we think the smartest approach is. Because as you remember, Bert, early on when this program was stood up, we were challenged by the administration and by Congress for getting this rocket done by 2016. So there was some expediency, and you know, the logic was, well, can we get there? How much heritage hardware can we leverage to meet the mandate from Congress? And so the design that we came up with is what you see today. And as I mentioned earlier, these upgrades for Block 1B and these upgrades for Block 2 are going to introduce more capability. Namely, Block 1B has got the exploration upper stage, as I mentioned earlier. That's going to give us more TLI capability, and then of course Block 2. The plan is, since we're going to be running out of steel cases on the boosters, the booster office working with Northrop Grumman is coming up with a more advanced booster for the 9th flight.
Great. Question from Bill. Any planned design improvements to be worked in for the builds of the RS-25 serial number 17 and higher, or will we just be sticking to the existing designs?
No, it's Johnny Heflin's team. Let me step back. Steve Wofford, who was the element manager when this program was early on, challenged Aerojet Rocketdyne to do things more efficiently, simpler designs where we can, because recall the SSMEs were, you know, 70s, a lot of 70s technology. So I will tell you that that Johnny Heflin's team today his partnered NASA Aerojet Rocketdyne team are committed to, for engine 17 and subsequent, to build them smarter, more efficient, less parts, less hazards they have to deal with, and with higher thrust capability. So, as you guys know, we're currently at 109%. A lot of the Heritage shuttle thrust capabilities for the engines are still in play for the first couple of flights, but Johnny's team is also committed to increasing that power level. So we're looking for, Johnny's team is challenging AR to build them more efficiently, less parts, higher thrust.
Great. I just want to point out to everybody that Twyla Schneider from NASA Communications has been posting some information into the chat with some links and some more specific answers to some of the questions, including like the workforce. So I would encourage people to just take a look at the chat as well. And we're getting close to the end, Brian. Just in terms of the program as you've seen it develop, is there anything that might have been done to improve the process, or what I'll say more about lessons learned. What do you think the main lessons learned have been putting this whole program together?
I think the efficiencies, I'll point to CS1, to core stage 1, first build, first design, the time that it took us to build core stage 1, and what we're doing to from those lessons learned and incorporating those in the core stage 2 have been pretty significant, Bert. I think I quoted some numbers. Some of our efficiencies are 50% more efficient on throughput. I'm looking for some numbers I can quote you here, so I'm not misquoting. I saw some earlier. I'm going to get you these numbers because that's
okay, great. Any other questions, everybody? I think one more or two came in. Let me just take a look let's see.
Yeah, I'll go as long as you want tonight.
Okay.
I can't find these numbers, but I know, Twyla, that you've provided them to me. I will just say, again, I'll echo a lot of what the Boeing NASA team down at Michoud has learned with CS1 in terms of efficiencies in the planning and in the manufacturing of CS1. They have incorporated, and the NASA Boeing team has seen pretty significant efficiencies in the build of CS2, and I think that probably is one of the biggest lessons learned that I think that I can share with you. I will also tell you, again, this is first flight. This is STS1, folks. All right, let me look at some of these numbers here. Okay, so I'll just quote you some numbers here. CS2 is currently averaging 50% improvement in schedule over Artemis I. We've seen 70% improvement in labor hours on the engine section, 33% improvement on the intertank, 97% improvement in rework hours, and overall 70% improvement in baseline labor hours required. So I think that speaks for itself. The folks, I will tell you from a booster standpoint, That's the old ATK backhaul folks that are now Northrop Grumman. A lot of my old friends from Shuttle are still living in Utah and still work out at the plant. And so we've got we've got that experience that we can lean on. Incredible amount of experience from both them and our AR friends out in California that we were always looking to do things better. I will also say that we're coming up with our own lessons learned. We're working with the Kennedy guys on how to stack this rocket. And again, first time through, a somewhat of a new crew. We've got some of the KSC heritage folks from Shuttle that are there that are help guiding the task folks. But again, we're learning there. And Artemis II rocket, I am expecting I'm expecting the Kennedy guys, the Kennedy leaders, Cliff Lanham, who is our launch flow director for the first rocket. His team is certainly going to have lessons learned that they can incorporate into Artemis II, and we'll be right there with them. So yeah, we're going to learn a lot off of this first rocket, and we're already incorporating it into future builds.
There was one last question that came in, and I think you had touched on it, but I'm not sure everyone is clear about it. But I'll ask the question as it was written, and you can touch on it. And this is from Ronnie. What happens once you run out of Space Shuttle era RS-25 engines? Does Rocketdyne make more? And would newer ones being less weight, less cost, since they would not be designed to be reusable?
Yeah, I think I mentioned that earlier. The Johnny Heflin's team, his liquid engine office team, aka the old SSME team from Shuttle, they've already got that contract set up with Aerojet Rocketdyne. We call it the production restart contract. And that contract is basically gives the AR folks the go to start building the 17th and sub. And I know that I've got a stat in here somewhere, but they're basically on contract to build. I'm gonna find this number too, and I want to get this right. Yes, let me quote you here. Production of the first six new restart engines has started, and there are a total of 24 on contract. And as I mentioned before, we are incentivizing and we are motivating AR to build these to be more efficient, less parts, taking advantage of today's technologies that will then translate into higher performance of these engines that we're going to need out in the future, starting with Artemis V.
Very good. Thank you so much, Brian. I think with that, we're going to close out for the evening. We really appreciate you taking the time out of your busy schedule to come and share this. This is really exciting, really interesting. And I think I can say on behalf of all of us at the NSS, we're wishing you all and your entire team great success with that first launch. We look forward to watching it. So we really do appreciate everything you shared this evening. So thank you so much. And
thank you. And again, I hope all you guys are as inspired as I am. I am so fired up about launching this first bird. You just can't imagine. So, and thank you for having me tonight. Anytime I get the opportunity to share with space advocates what we're doing for the agency and for this nation, I love doing it. So I want to say thanks to everybody that tuned in tonight, and I do appreciate your participation.
Thanks again. I would like to also thank Twyla Schneider from NASA Communications, who helped get us organized and provided some great answers in the chat. So thank you so much. Also like to thank Robin Scott from the Huntsville L5 Society, again, for jointly sponsoring this. And my NSS colleagues, of course, Larry Ahern, Vice President of Chapters, for being my co-coordinator and getting all these space forums organized. Alif Martin, our social media manager, and of course, the incomparable Fred Becker, who always does a great job in handling the technology and monitoring all the activities. So thank you all for all you do to help get these space forums on the road. And again, I'd like to thank all of you who are participating. What I'm going to do is share my screen one last time. And just to close out the slides, there we go. And so again, everybody, we really appreciate you joining us this evening. We look forward to seeing you again in 2 weeks for David Chudwin. And again, we will be posting this recording to our YouTube channel. And I will be sending a link out to all the people who registered, including those who were not able to make tonight's presentation. So they will be able to see this. So again, thank you all for attending. Wishing you a great evening for those in our time zones. I know we get a lot of people from the next time zones into tomorrow. So I hope you have a great day and of course a great weekend, and wishing everybody, staying safe. So again, thank you all and wishing you a very good night.